Hi friends, welcome to our aimstoday YouTube channel. In today's IIT-JEE Foundation class from Mathematics subject, polynomials topic we are going to discuss. Now first let's know what a polynomial is. A polynomials look like the below example. So if you observe the example here, 4xy square plus 3x minus 5, it is an expression. So the polynomial looks like this mathematical expression. So 4xy square is a term, 3x is the second term, so minus 5 is the third term. So this is an example of polynomial having three terms. We know the meaning of term actually. Actually term means it's a combination of two parts. Here 4 is the numerical part, or we call it as coefficient, and xy square is the variable part. A combination of numerical part and variable part is called as a term. Like this, in the given expression, we are having three terms, and the combination of three terms combined by symbols like addition, subtraction, or product is called as a polynomial. So this polynomial, it comes from two words. One is poly, which means many. Another one is nomial, which means term. So a polynomial means an expression having many terms. So a polynomial can have constants like 3, minus 20, 1 by 2, or root 2. Like that, it may contain terms. Means it may contain positive integers or negative integers or numbers like fractions or constant numbers like root 2. It also can have variables like x and y. It also has exponents like 2 in y square. In y square, 2 is considered as exponent. But here, one condition is very, very important. A polynomial can contain exponents, but the condition is for the expression only these numbers are allowed. The numbers like 0, 1, 2, 3, dash, 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 and so on. Like that, numbers are only allowed. Means the exponent can take only the values of whole numbers or non-negative integers. Only that are allowed. So these constants, variables, and exponents, all these can be combined using the operations like addition, subtraction, multiplication, and sometimes division. Actually, in most of the definitions, they won't include the word division. Why means a polynomial can have a division, but the condition is the division should not be by a variable. Means like 2 by x. Here in the division is done by the variable x. So these kind of divisions are not allowed in the polynomials. So that's why in most of the common definitions, we won't find the operation like division. So a polynomial, it can have constants, variables, exponents. These are all can be combined together using operations like addition, subtraction, multiplication, and division, but the condition applies. So a polynomial can have consonants, variables, exponents, but never division by a variable. That is the normal definition of a polynomial. They can have one or more terms, but not infinite terms. So this word we have to keep in mind. So a polynomial should never contain infinite number of terms. If an expression has infinite number of terms, then it is not a polynomial. So let's see some more examples. So here in this example, 5xy square, it is the first term, minus 3x second term, plus 5y cube third term, minus 3 fourth term. Here we are having four terms. These all four terms, what we have to see, they are containing constants like 5 minus 3 plus 5 minus 3, okay. Variables like xy square, xy cube, okay. Combined by operations like here product is there, between 5 and xy square product is there, and minus subtraction is there, plus addition is there. That is one thing. If we observe the exponents, here 2, positive integer. Here there is nothing, means we have to assume there is 1. 1 is allowed. Here 3. Here there is no variable. So we can take it as x power 0. When there is no variable, we can take it as x power 0, because the value of any variable to the power of 0 will always be 1. 3 into 1 equals 3 only. So here this expression is having the exponents like 0, 1, 2, 3. So all exponents belongs to whole numbers. So all are non-negative exponents. So that's why this example we can consider as a polynomial. If you take the example like 3xy to the power of minus 2, here in the place of exponent we have minus 2, which is not a whole number and which is negative integer. So that's why this kind of expressions are not polynomials. So this one also, 2 by x plus 2. In the denominator part, variable is there. Means division is done by the variable. So this is also not a polynomial. So we can tell the expression is a polynomial or not a polynomial based on the given conditions. So let's see some more examples. So 3x, only one term is there. A combination of coefficient or number part and variable part. This is the polynomial. X minus 2. 2 terms are there, polynomial. Here also two terms are there. And one division also is there. But in the division is done by the constants. So no problem. It's a polynomial. Next, 1, 2, 3, 4, 5. 5 terms are there. In one term, decimal point is there. No need to worry. It is also a kind of polynomial. Next, 2 terms are there. Here the exponent is 5. Here also exponent is 5. It is also a polynomial. Now 5. 5 means only constant. Only constant term also is considered as polynomial. Why means if there is nothing means we can assume it as 5x to the power of 0. We can take it as 5x to the power of 0. So it is also one kind of polynomial. So now whatever examples we have mentioned here, these are all polynomials. Let's take some more example. 3xy to the power of minus 2. Here in the power, in the exponent place, we have minus 2, which is not a whole number. So that's why this is not a polynomial. 2 by x plus 2. In the denominator part, variable is there. It is also not a polynomial. 1 by x. Denominator part, variable is there. It is also not a polynomial. Root x. If we elaborate root x, we can write it as x to the power of 1 by 2. So in the exponent place, we have 1 by 2. 1 by 2 is not a whole number. 1 by 2 is not a whole number. So it's a fractional exponent. So this is also not an example of polynomial. So whatever 4 examples we have taken, these are all not polynomials. If you take some more examples like this, x by 2. If we have a term x by 2, here division is done by the number or constant. So that's why it is this kind of polynomials are allowed. It's a polynomial. 3x by 8. Same case, same reason. Here also division is done by the constant. It's a polynomial. Root 2. Only one term, constant term. Root 2 is having a constant value. 1.4142 and so on. It is also one kind of polynomial. So these kind of polynomials are allowed. We can take polynomials like that. Types of polynomials. So before going to discuss about types of polynomials, let's take the examples of some cycles. So this cycle is having only one wheel, one tire. One tire means we use the word monocycle. Here 2 tires are there, bicycle. We can call it as bicycle. Here 3 wheels are there or 3 tires are there. We can call it as tricycle. So cycles based on the number of wheels, we have divided them into monocycle, bicycle, tricycle. In the same way, polynomials they are also classified as follows. So we have a term like 3xy square. Now it's considered as one term, product of numerical part and coefficient part. Numerical part and variable part. It's a monomial. The expression having only one term. So this is an example of polynomial. 5x minus 1, binomial. It is having 2 terms. One is 5x, another one is minus 1. It's an example of expression having 2 terms. It is called as binomial. because it is having two terms. This is also an example of polynomial. Next, 3x plus 5y square minus 3. Here, three terms are there. So that's why it is called trinomial. Expression having three terms. This is also an example of polynomial. Like that, we can also have terms, expressions having four terms, which are called quadrinomials, and expressions having five terms, which are called as quintinomials. Actually, for this number of terms, for these expressions, we are having the special names, but those names are not often used. Even binomial, trinomial, these two expressions also, they are considered as polynomials. So normally the mathematical expressions consisting of two or more terms, are all considered as polynomials. So except monomial, remaining all terms, they are considered as, all expressions, they are considered as polynomials. Let's continue the topic in our next video. Last video we have discussed some basics of polynomials. So what is a polynomial? What does it consist of? What is the term? What is numerical coefficient? What is the variable part? What is the condition of exponents for becoming a polynomial? Like that, some basics we have discussed. So in today's video, we are going to learn some more details regarding the polynomials. So the general expression of polynomials is given by the following equation. So here, if you observe here, we have p of x. So it means we have defined a polynomial p in terms of variable x, and it is defined in this way. So an x power n first term, a n minus 1 x power n minus 1 second term, a n minus 2 x power n minus 2 third term, and so on, a0 x power 0 last term. So like that, some finite number of terms are there, starting from an x power n to a0 x power 0. If you observe here, in all these terms here, an and an minus 1, an minus 2, an minus 3, a0, these are all considered as coefficients for the variables in each term, or we can call them as numerical parts for the existing variable parts. So these are all considered as the coefficients. So here n minus 1, n minus 2, n minus 3, 0, these are all considered as exponents. So the largest exponent of this expression is n. The largest exponent of this expression, total expression, is n. So this n is considered as degree of the polynomial. So normally degree means, so whatever highest power is there, out of all the terms, if we check the exponent of each term, so the highest exponent or highest degree of each individual monomial is considered as degree of the entire polynomial. So here, as n is the highest degree compared to all other exponents, so here n is the degree of the polynomial, because first one is n. Next exponent we have n minus 1. So means 1 less than n. n minus 2, again 1 less than n minus 1. Here the exponents are decreasing one by one. Ultimately they are coming to 0. So that's why n is considered as degree of the polynomial. So this the polynomial, it can be called as nth degree polynomial. As its degree is n, we can call it as nth degree polynomial. So this is the standard of a polynomial in descending powers of x. If you observe the exponents also, here x power n is there. For next term, the variable is x, but the power is n minus 1. So here the powers are decreasing for the variables, same variable. So that's why this is the standard form of polynomial in descending powers of x. So the term an x power n, so this beginning term, it is considered as the leading term. So from the leading terms, so if we go on decreasing one by one to the power, we can form this polynomial. So that's why this is considered as leading term. Here, in this, each term is considered as a power function. Each term is considered as a power function. So a power function is a function in which single term, if you take any single term, so that will be the product of a real number like a n minus 3 and a real number a n minus 3 and which is nothing but a coefficient and a variable x raised to a fixed real number of power like n minus 3. So this is considered as a real function. Like this, in the general expression of polynomial, all the individual terms are considered as power functions. So like this we can write the general expression of a polynomial. So next, let's see degree of a polynomial. So normally the degree means we come across different meanings in different aspects. So in geometry part, degree means measuring angles. So but in algebra, degree is sometimes called as order of the polynomial. So the degree of polynomial is highest degrees of the polynomials, monomials. So each monomial will be having some exponent that is called degree of that monomial or that individual term. Out of all the degrees of individual terms, the highest degree will be considered as degree of the polynomial. But the condition, all should exist with non-zero coefficients. All the terms should exist with non-zero coefficients. So then only the term will be considered. Or if we have a term like x square y to the power of 3, if we have a term like this, 3x square by 5 to the power of y to the power of 3. So in this term, for single term only, we have two variables. So at that time, the degree of the term will be the sum of the all exponents of the variables. So 2 plus 3. So here the degree will be 5. So which is a non-negative integer. So we can take one more example like this, 7x square y cube plus 4x minus 9. So which can also be expressed as, so here these two are okay, but here in the first term we have both the variables x and y, but in second term the variable y is missing and x is not having any exponent there. So for the variable x we can take 1 as the exponents, because nothing is mentioned is there means 1 we can take. So as there is no variable relating to y, we can take y power 0. So the second term 4x will be written as 4x to the power of 1, y to the power of 0. In the third term, both the variables are missing. So that's why we can write them as x power 0, y power 0. So here, so the given expression is having 3 terms. So out of 3 terms, the first term is having a degree of 5, sum of 2 and 3. Second term is having a degree of 1, because 1 plus 0 is 1. And the last term, 0 plus 0 is 0. Last term having a degree of 0. So 3 terms are having 3 different degrees. So you have to understand carefully. So each individual term will have 1 degree. Like that, for the first term degree is 5, second term degree is 1, and third term degree is 0. Out of 5, 1, 0, which is the highest degree? 5 is the highest degree. So the highest degree will be considered as highest degree of the polynomial. Highest degree of the polynomial. So based on the degree, we can name the polynomials. Suppose we have polynomials like this, 7, x plus 3, x square minus x plus 2, x cube minus x square plus 5. Like this, we have some examples. So if we observe here, so 7, so there is nothing. We can write there is no variable. We can take it as 7x to the power of 0. What is the degree here? 0. Next, x plus 3. Here on the variable exponent is not mentioned. So you can take it as 1. So here no variable. You can take x power 0. So out of 1 and 0, which is what is the highest? 1. So degree of this example, this polynomial will be 1. Like this, for this polynomial it is 2. So for this it is 3. So for this it is 4. And for this it is 5. Now based on the degrees, we can name them as the degree is 0. So that will be called as a constant polynomial. So here, if we have only constant polynomial, if we have only constant number, so then that constant number also is considered as a polynomial, and its name is constant polynomial, or we can also call it as 0 degree polynomial. So here, if the degree is 1, linear polynomial or first degree polynomial. If the degree is 2, quadratic polynomial or second degree polynomial. Like this, cubic polynomial, quadratic polynomial, and quintic polynomial. Like that, based on the degree, we can name the polynomials. Suppose they may ask this one, which kind of polynomial is there? It is having more than one variable. Here the degree is, now for the x, there is no exponent, we can take it as 1. 1 plus 2, 3. So here the highest degree is 3. So that's why this is called as a cubic polynomial or third degree polynomial. Like that, you may get questions by giving some polynomials, and they will ask you to identify what is the name of this polynomial. Then you have to give the answer based on the highest degree of compared to all the terms. Let's see some example problems. So what is the degree of the polynomial? Here 4 options are there. 3 plus 2, 5. 2 plus 3, 5. Here nothing is there. 1 plus 3, 4. 2 plus 2, 4. Here nothing is there. 1 plus 1, 2. Here 6 means x power 0. Here degree is 0. So out of all the degrees of individual terms, here 3 plus 2, 5. Here 2 plus 3, 5. Two terms are having highest degree 5. So the degrees of two terms are 5 and 5. So the degree of this polynomial will be 5. So 5 will be the right answer. So next, see another example. What is the degree of the polynomial given below? So here first term, 4x square, y to the power of 5, 2 plus 5, degree is 7. Second term, x cube by cube, 3 plus 3, 6. Next, xy to the power of 7, x1 we can take, 1 plus 7, 8. Next, x to the power of 5, y square, 5 plus 2, 7. So for the last one, y power 6 means there is no x. Degree is 6. So out of all the degrees, what is the highest degree? 8. So 8 will be the right answer. So next example. So what is the degree of product of two expressions? Here they have given two expressions are there. Each expression is having 3 terms. Now they are asking degree of the product of two expressions. If you multiply these two, one expression will come. For that expression, we have to find the degrees of all the terms. Then highest degree will be considered as degree of the polynomial. So we have to multiply. We have to multiply both the polynomials. Then we will get individual terms 1, 2, 3, 4, 5, 6, 7, 8, 9. Here 3 terms are there. Here 3 terms are there. If you multiply all together, 9 terms we will get. After simplification, like this we can write 1, 2, 3, 4, 5, 6, 7. Similar terms we can add and we can subtract. After simplification, we will get 7 terms. Out of 7 terms, here 4 plus 2, 6. So this term is having highest degree. So the answer is 6. So like that, in the questions they may give two expressions. At the time, what you have to do, you have to do the product of both the expressions, and based on the after the simplification, you have to give the answer. Some shortcuts also are there, which we are going to learn in further videos. Let's see another example. So here the degree of polynomial, like a fraction it is given, but we have to find the degree of the polynomial for this fraction kind of polynomials. So first for numerator part, so the numerator part degree is 5. For the denominator part also we have to find the degree, that is 2. We have to subtract both. 5 minus 2 equal to 3. So therefore 3 will be the degree of this quotient type kind of polynomial or fraction kind of polynomial. So if they give quotients in terms of in the place of expressions, so then what you have to do, you have to find the degree of the numerator first, then denominator you have to subtract both. So whatever value you are getting, so that will be the degree of the given quotient kind of polynomial. Let's see the value of the polynomial. How to find the value of a polynomial. So a polynomial in any variable such as x is symbolically represented as p of x, f of x, g of x, etc., which we have learnt already. So the alphabets like p, f, z, either in small letters or capital letters, are used for naming the polynomials. So the value of polynomial p of x, if the value of variable x is alpha, then at that value, at alpha, the polynomial will have some value, and that value is denoted by p of alpha. Means p of alpha is the value of the polynomial p of x at x equal to alpha. So consider a polynomial. Here they have given a cubic polynomial, 5x cube minus 2x square plus 3x minus 2. 4 terms are there. So we have to find the value of the polynomial at 1. We have to find the value of polynomial p of x at 1. Means the variable value is 1. So then how to find that value? So we have to replace x everywhere in the given polynomial equation, in this entire equation, everywhere, wherever we find the value x, there we have to replace it with 1. So then it will be termed as p of 1. Means the value of p of x at variable x equal to 1, denoted by p of 1. So here 5 is there, coefficient 5 we will keep like that only. In the place of x we will keep 1, so then it will become 1 cube. Next 2 as it is. Next x square we keep 1 square. Next 3x means 3 into 1. Constant term it will be like that only. So like that we replace all the x terms with 1. So which is equal to, so 1 cube means 1 only, 1 into 5, 5. So 2 into 1, 2, 3 into 1, 3, minus 2. After simplification, the value is minus 4. So we say that the value of p of x, so the value of given polynomial at variable x equal to 1 is minus 4. Is minus 4. Sorry, it's not minus 4, plus 4. 5 plus 3, 8. Out of 8, if we remove my 4, then it will become plus 4. So the value of polynomial is plus 4. So next, how to find zeros or roots of a polynomial? So actually, the value of polynomial p of x, if you place alpha in the place of x, if the value of polynomial is 0, then p of alpha equal to 0. So then alpha is called 0 of the polynomial p of x. So they have given a polynomial p of x, and we have taken a variable value as alpha. If we take alpha in the place of x, if the polynomial value is becoming 0, then that alpha, whatever variable value we have taken, that alpha is considered as 0 of the given polynomial. So let's see one example. So here they have given one polynomial f of x, which is defined as 2x square minus x minus 1. So if you place 1 here, f of 1, so what happens? 2 1 square minus 1, minus 1. Ultimately, the value will become 0. Means when we are keeping the value 1 in the place of variable x, then entire polynomial is becoming 0. So that's why for this polynomial, 1 will be considered as 0 of this polynomial or root of the given polynomial. So x equal to 1. So x equal to 1 is the 0 or root of the given polynomial f of x. So here we have to remember, keep in mind some things. So suppose they have given one polynomial like p of x equal to 0. So the given polynomial itself is a 0 polynomial. So because its value is always 0, we call it as 0 polynomial. So the given polynomial itself is 0 polynomial. So that's why in the place of x, we can keep any real number. We can keep 1, we can keep minus 1. Like that, we can keep any real number. For any kind of real number, the value will be always 0. So for 0 polynomial, every real number will be a 0. Next. Suppose one minute. Suppose I have a polynomial like p of x equal to 5. P of x equal to 5. So here we have only constant. I mean, there is no variable. If it is variable, we have to assume it is x power 0 like that. Here this is an example of constant polynomial. Constant polynomial. This is an example of constant polynomial. So here if you place 1, p of 1 equal to 5, p of 2 equal to 5, p of 3 equal to 5. So like that, for any kind of variable, the value will always be a constant but never be 0. But never be 0. Means a non-zero constant polynomial has no 0. So 0 doesn't exist for non-zero constant polynomial. So that is second point. Next. So we have a linear polynomial like p of x equal to x plus 1. So if you place which value in the place of x, then it will become 0. Just by observing we can tell. We can keep minus 1. If we take x value minus 1, then minus 1 plus 1 cancels each other. Value will become 0. So there exists one variable, one value for the variable which is considered as 0. So the polynomial will always have a unique 0 value, one and only one value. So for linear polynomial, there always exists a unique 0. Means only for one value only it can become 0. So we have, let's take the example of quadratic polynomial like x square plus 3x minus 4. So by observing this, if you place if you take the value of 4 in the place of x, what happens? 4 square 16, 3 4s are 12, minus 4. Or else if we take minus 4, then what happens? 16 minus 12 minus 4 plus 16 minus 16 cancels each other. So for the value of minus 4, this quadratic polynomial will become 0. So minus 4 is one answer, one solution for this quadratic polynomial. Or if we take 1, at that time also 1 square minus 4 minus 3, here minus 3 will come, plus 3 will come, minus 3 plus 3 cancels each other, then also it will become 0. So if we take 1 also, this quadratic polynomial will become 0. So for this quadratic polynomial, there exists two zeros. So in the similar way, for cubic polynomial also, if we solve any kind of cubic polynomial, they will have 3 zeros. So these things are very, very important. We have to keep in mind. So for a 0 polynomial, any real number will be the 0. For non-zero constant polynomial, there is no 0. For linear polynomial, there always exists a unique 0. Only 1 0 will be there. For quadratic polynomial, 2 zeros will exist. For cubic polynomial, 3 zeros will exist. So like that, here 0 means the value of variable at which the given polynomial will become 0. The number of zeros will depend on the types of the polynomials, whether it is 0 or non-constant, linear, quadratic, cubic polynomial. Basing on the types of polynomials, we can define the zeros of the polynomials. Let's see some solved examples based on the present topic. Suppose here, if you observe this question, x equal to 4 by 3 is root of the polynomial or 0 of the polynomial for f of x. They have given the value of f of x. So in the polynomial, there is along with x, there is a variable k. We have to find the value of k. The hint here is they have given 0 of the polynomial. So they have given the polynomial, they have given 0 of polynomial. We have to find the unknown term k. Unknown term k here. So let's write the polynomial as it is. So they have given that 4 by 3 is the root. Means in the place of x, if I keep 4 by 3, so then total polynomial value will become 0. That we know from basic definition of 0 of polynomial. So everywhere we have to replace x with 4 by 3. Then 6x cube, 4 by 3 whole cube, 4 by 3 whole square, 4 by 3. Like that we will replace the values of x. Next here we can write like this: 4 cube 64, 3 cube 27. Here 4 square 16, 3 cube 3 square 9. Like that we will write. After simplification, 3 2s are 3 3s are. Like that, after simplification, the first term will become 128, second term will become 176, third term will become 12k, fourth term, after taking LCM and multiplying, fourth term will become 180. So after simplification, further if you go on simplification, so their 12k value will be 228, k value will be 19. Like that, for a given polynomial, if there is any unknown term, if the 0 is given, so with the help of 0, we can find that unknown term. So you can come across these kind of examples based on this topic. Let's see one more example. If x equal to 2 and x equal to 0 are the roots of polynomials. Two roots. One polynomial is there, 2x cube minus 5x square plus ax plus b. For that, two roots are given. So in the polynomial, they are asking to find us the value of a and b. Means two unknown terms. Two unknown terms a and b are there. Along with the variable x, we have to find the values of unknown terms, unknown variables, a and b. So they have given 2 is the root of the polynomial. So means in the place of x, if we keep 2, the polynomial value will become 0. So everywhere we have to keep 2. So after simplification, so what we will get? 2a plus b equal to 4. Let it be the first equation. Next, let's use this one, second 0 this time. Means in the place of x we can keep 0 everywhere. So then its value will become 0. So here all zeros we can keep. So after simplification, b equal to 0. This is the second equation. By placing first 0, we got first equation. By placing second 0, we got second equation. Now these two equations we have to solve from 1 and 2. From 1 and 2 equations. In the place of 2a plus b equal to 4, in the place of b, I can keep 0. So then what happens? 2a plus 0 equal to 4. Means 2a equal to 4. So a equal to 2. So what values we got? Finally we got a is equal to 2 and b equal to 0. So like that, if they give two roots and two unknown variables, then also with the help of given roots, we can find the two unknown values. So let's continue the topic in next video. So thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you.